This time, I'm going to talk about ridge regression in Python. So what is ridge regression? Ridge regression is a technique for analyzing multiple regression data that suffer from multicollinearity. I have another video talking about multicollinearity in my YouTube channel. You are welcome to watch that video first. When multicollinearity occurs, these squares estimates are unbiased, but their variances are large, so they may be far from the true value. So what is bias? Let's say our true data is in the center of this circle, and all those cross marks is our estimate. If our estimates are here, where it's far off from the center of the true data, we will say our estimates have high bias. If our estimates are in the center of this true data, we will say our estimates have low bias. Then what is variance? Variance means our estimates are not clustered in one place. Instead, our estimates are all over the place. If our estimates are all scattered around here, which our center is not consistent with the true data center, we will say we have high bias and also we have high variance. How about our center is also the center of the true data, but our estimates are scattered around. This is called overfitting. In this graph, we are saying the true data are located in the center of this circle, but in most of the cases, we really don't know where the true data are. Let's say we have our data in these blue dots. If we try to fit our experiment data with this curve, you can see we have high variance, and this is overfitting. It fits our experimental data so well, but we don't know if all those experimental data can present all our true data. In the second graph, you can see our result is a straight line, and it doesn't fit our experimental data at all. This is called underfitting. In the third graph, you can see it has a good balance. It fits the data, but not overfitting. It has low bias and low variance. Let's see this graph. The blue dots present our training data, and all those orange dots present our test data. If we had overfitting, you can see our curve fit all those training data perfectly. But when you measure with all those test data with the orange color, it doesn't fit very well. If we had a very balanced result, you can see it fit the training data, also it fit the test data quite well. The most common regression method is least squares regression. Least squares regression doesn't differentiate important from less important predictors in a model, so it includes all of them. Ridge regression avoids all of these problems, while least squares produces unbiased estimate, but it doesn't care about variances. So variances can be very large. While ridge regression consider bias and also consider variances. So ridge regression has just enough bias to make the estimates reasonable, reliable approximations to true population values. Now let's take a look at this graph. The horizontal axis shows the model complexity. So to this direction, the model will become more complex. And the vertical axis shows the error. When the model becomes more and more complex, you can see the bias drop down, but the variance can rise up. And least square estimates stand here. It means if you increase the complexity of the model, the bias will become smaller and smaller. But it has a problem of overfitting. The variance can jump up. If you simplify this model, the bias will increase, but the variance will drop. So where should we stop? We should stop in the middle. We have enough complexity of this model, and we have reasonable bias and reasonable variances. This is a cost function of simple linear regression. With simple linear regression, we only care about the difference between our experimental data and our calculated data value. Let's take a look at the cost function of ridge regression. You can see this part is the same between this simple linear regression and ridge regression. But for ridge regression, we have an extra item here. This item is adding a penalty equivalent to squares of the magnitude of the coefficients. You can see there is a parameter lambda here. This parameter is very important. If lambda is 0, you can see the cost function of ridge regression will become same as the cost function of simple linear regression. But when lambda increases to a very large number, you can see we put a lot of penalty to these coefficients. Now let's go to Python to see how do we implement ridge regression. In this example, I use some housing data. You can see I have 506 example data here, and I have crime rate, average number of rooms, age of the house, and the full value property tax rate, etc., all those parameters. And from all those independent variables, I want to estimate the value of the house. First, I run the linear regression, and you can see for all those independent variables, I got all those estimates. As I mentioned before, with the linear regression, we don't know how important those independent variables are. They just gave us some linear regression estimates here. Now, if we use ridge regression, you can see I changed lambda. I mentioned in this cost function for the ridge regression, lambda right here. So if I increase lambda, you can see our estimates changed. For demonstration purpose, I only pick up 5 important independent variables here. You can see, for example, for room, even though the lambda increased to 200, the room, this independent variable, still remain very important. While another parameter, this one, the blue one, is the highway access, you see it dropped significantly. That means when we increase lambda, when we put more penalty to all those independent variables, the highway access become less important. Although in this graph, it will show us how important those independent variables are, we don't know what the best lambda is. We don't know if we should stop here to pick up the lambda or stop here. Now, let's decide what kind of lambda we should pick up. We calculated ridge regression R squared. This blue line is for the training set, and the red line is for the test set. Let's take a look at the test set. You can see with the OLS R squared, because with the linear regression, we don't have lambda involved. So this will be constant with this green dot line. With this ridge regression, when we increase lambda, you can see the R squared first came up and then dropped down. And here we have the maximum R squared is about 0.7 and the lambda was 8. So we know the best lambda we should use for our model is 8. This is why we use ridge regression and how we implement it in Python. Please provide your comments and subscribe to my YouTube channel. Thank you very much for watching.